In ECU 111, lecture 13, set 4, we talked about how adders can be efficiently implemented, but this is not exactly always, the case that you need to optimize every adder in Verilog. In fact, when you write Verilog, there is, the arithmetic plus operator here, which you could use within, say, an assign operation for combinational logic, and it actually has these pre-made adders that can help you compile into adder circuits. Now, what happens here is that you could actually do this addition by having this signed values added. So in this particular case, we're trying to have one bit added to these, but then have this carry and kind of sum computed in this case. But you could also have this scaling in using Verilog, and then scaling is usually done by scaling by power of 2 means that you could shift to the left k place. Remember that number system we described? So the first bit was 2 to the power 0, the second one was 2 to the power 1, and so on and so forth. So every time you shift, it's just like you're kind of going going kind of to the scaling to the power of 2. And so if we have, for example, this number which is sorry which we are trying to multiply by 2 to the power 3. That means that, this is, this is actually a base 2. I'm going to correct this in the slides. So if this is, ignore this 2 here. So the value here is 0, 1, 1, 0, 0, 1, 0, 0, 0, and this is in base 2. And if we are shifting this by k places, that means that we are putting that number here. So we are shifting by 3 places. That means we're putting this here. And in this case, this means that this is this number multiplied by 2 to the power 3. And if we need to fit this in n bits, we need to truncate it. Remember we truncated from the most significant bits out there, so we kept those least significant bits. And if the most significant bits have a 1, that means we are truncating and we are throwing out some information. So you have to be very careful about truncating in that sense. And then the other thing that can be done is that you could actually divide by 2, and again this should be similar to this one, this 2, and then if you're dividing, that means that we are shifting this to the right, and then we are removing those 3 bits. I'm going to edit that in the final set of slides that is uploaded. Again, as you have seen, shift left and shift right can work as a multiplication by power of 2 or division by power of 2, and that is something that we could use for for our numbers. So when we shift by 2, that means that we are doing the computation like that. And if you're rotating by 2, that means that we are dividing by that. So in this particular example, 19 times 2, 19 times 2 to the power 2 is 76, which you could actually see this happens in base 10. Also, 19 divided by 2 to the power 2 is 19 divided by 4, which is, if you're truncating the numbers, that means that it's a 4 in base 10. Of course, it's 4 point something, but we're only here talking about integer numbers. In the next set, we will be talking about multiplication.